So in this video, we're going to look at example 5. But before we do that, I want us to scroll ahead to more pages in our workbook to look at the official substitution rule in this squared off box here. So I just want us to get a taste of what this formal rule says, and then we'll look at the example. So the rule says if f is a function with a known antiderivative, so that means we know that big F of x, we know some big F of x, the derivative is equal to little f, which means the integral of little f is equal to big F. Okay, so we know this. We know what big F is, the antiderivative is. Okay, now let's keep reading. We can choose u, so we can substitute u for a function g of x to obtain the following formula. So we can look at the integral of f, g of x, times the derivative of g is equal to just f of u. Meaning if I had u substituted for g, and I had du here, then that just becomes the integral of f of u du, which is exactly what I have written here when we've substituted the u and the du. Okay, this might look a little foreign, so let's look at example 5 to really make sense of it. And the more problems like we do like this, the more comfortable you're really going to feel with this substitution rule. All right, so we're going to use that substitution rule. So we need to find a function like g of x to sub in for u. And then after that, we're going to compute the derivative of u with respect to x. And we're going to hope to identify a du and a u in our original integral. Okay, so if we just kind of reflect on this integral, we can see there's a relationship. There's an x cubed here, and then we see the derivative of that x cubed coming out here. So let's go ahead and let u equal x cubed. So that means the derivative of u with respect to x would equal 3x squared. So now let's go ahead and make our substitution. So this means the integral of 3x squared cosine of x cubed dx is equal to, just substituting what I have here, is equal to the integral of du dx times the cosine of u dx. So notice what happens here with this dx's. They cancel each other out. So I just have an integral with respect to u. So one thing in some videos you might see on YouTube or some other methods is that at this stage, people will multiply both sides by dx right away, just so that in our substitution, we only have a u and a du that we're substituting, so that we can take care right away to remove any dx's. So we can go straight from here to then the integral of cosine u du. Awesome. So the substitution rule says that this is legitimate. It says that we can convert a function using x's. If we're able to find a u and a du in that integral, we can make an equivalent integral just using u's. Okay, why is that helpful? Well, now what do we have? We have the integral of cosine of u. So now we can think about what the antiderivative of cosine of u is. So we need to know, what is a function whose derivative is cosine? Well, that's just equal to sine of u plus c, since we're looking at the general antiderivative. Awesome. So this first step here is from that substitution rule. I'll just say sub rule. Then this next step is just from computing antiderivatives. And so if we stopped here, we might be a little disheartened because the integral that we started with has x's in it, but the function that we give someone has u's in it. So the final step that we need to do then to finish off this problem is to substitute back in for u. So we look at, oh wait, what was u? It was x cubed. So everywhere that I see a u, I have to put in x cubed. So sine of x cubed is also equal to the sine of u plus c. So our final antiderivative is sine of x cubed. Awesome. Does this look familiar? You might notice that back in example 1, we also found this out, but we started with the function sine of x cubed. So in this example 5, we started with this integral not knowing what the antiderivative was. But we found that antiderivative by converting this integral into an integral using u's that simplified our function, simplified it from a cosine x cubed with a 3x squared into just a cosine u. Then we were able to take that antiderivative, and then that final step, just subbing back in. Oops, we need a smaller pen here. Subbing back in for u. All right, and there you have it. All right, so please take a moment to reflect on this video, rewatch any parts, and I'll meet you on the next example.